We're going to talk about simplifying radicals so that in a few days we can apply it to special right triangles. For some of you, this may be a review. For some of you, you may not have seen it at all. So we just need to make sure that we cover it. First and foremost, this little sign here, okay, that is a radical. So that is referred to as a radical. Now, also, like when we use the radical mathematically, what we're doing is that we're taking the square root. All right. So, because when we take the square root of a number, sometimes it ends up in like this long, ugly decimal, sometimes it's easier to just leave the square root, all right, in radical form, or you have also heard me refer to that as exact form. So when you leave it, say, as the square root of 29, because the square root of 29 is like 5.4, and we can just leave it as the square root of 29. So we do this, we leave it in radical form instead of using a calculator to find the approximate value. Or those are also referred to as decimals. So decimals you approximate because you're rounding. Radicals are exact because there's no rounding involved. All right, so we're going to talk about how to simplify. So even if we have like the square root of 78, we're going to talk about how to simplify that down even further and still keeping it in radical form. So to simplify radicals, to simplify square roots, we're going to look for what are called perfect squares. And this is like not really like the square, the shape. All right, we'll see in a second. Perfect squares are numbers that are whole numbers after you take the square root. Now, these numbers are, so 1 squared is 1, right? 1 squared equals 1. Then we have 2 squared equals 4. 3 squared equals 9. You keep going. So 4 squared will get you 16. 5 squared, 25. 6 squared is 36. 7 squared is 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared, 169. You can go on and on and on and on and on, but these probably are your most common ones. 1, 4, 9, all of these. You know, a lot of times also, like this is up to 13. You can also pretty much go up to, 14 or 15. Those are the most common ones. Well, I cannot tell you or stress to you enough, and I always stress the important things and try to get you to believe in me early on. These need to be memorized if they're not already. So when I ask you what are the perfect squares, you need to be able to rattle them off to me. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. Because these are perfect, because anytime you take like the square root of 4, you get 2. The square root of 9, you get 3. So anytime you take the square root of a perfect square, it's going to come out to a whole numbers. That's why it's called a perfect square, because it's perfect. It's nice and neat and pretty and whole. Okay, to simplify these. So to simplify these, we need to know our perfect squares. What we're going to do is look for the perfect square inside the number that is under the radical. You may have to factor the number, which we are going to factor the number to find the perfect square. All right, to find factors, so if you're bad with factoring, to find factors, you can use your calculator, and what you're going to do is in y equals, you're going to put whatever number you're trying to find factors of. So let's just say it's 46. You're going to go to y equals, the y equals button. You're going to put in the number that you wanted to find the factors of. So what number? Then you're going to divide that by x. And then you're going to go second graph, go to your table. So hit second, then hit graph. And what's going to happen is that's going to pull up your table. So remember, in your table is xy, and it'll have listed there the factors of that number. So what's going to happen is that we're going to look in these factors here for perfect squares. So if we find a perfect square, we're going to go ahead and take that square root because that's going to give us the whole number. Then we're going to multiply the root. This is the number that's coming out of the perfect radical. We're going to multiply that by what's left outside the radical, what's left inside the radical. When there is an existing number outside the radical, what we're going to do is we're going to multiply any root times that value. And this is all going to make more sense when we get into the examples. All right, so simplify the radical. So the square root of 20, it can be simplified further. Again, what we're going to do to simplify it is we're going to factor 20. So of the number 20, we're going to factor it. So we're going to look for factors. Okay, 1 times 20, 2 times 10, 3 doesn't go into it, 4 times 5. I think that's about it. Those are all of the factors that are whole numbers. So we're only looking for factors that are whole numbers. Now, we're looking through our list. We're looking for any perfect squares. And this is why you have to have the perfect squares memorized, because you need to be able to look at a list of numbers and identify the perfect square. So right here is a perfect square, okay, in 4. So these are the numbers we're going to use. So basically, 20 is 4 times 5. So the square root of 20 is the square root of 4 times the square root of 5. So we're using those factors to break apart, to split apart the number underneath. So here, this is what happens now. When you have a perfect square, you go ahead and take the square root. So the square root of 4 is 2. This is not perfect because if you take the square root of 5, it is a decimal. We're not looking for decimals. We want to keep everything nice and neat and pretty. So since square root of 5 is not perfect, you just multiply it by the number that came out of the square root. And when we say multiply, we mean that you're just going to set it up to that means it gets multiplied, because this reads as 2 times the square root of 5. So that's just how we write it, is that we write them right next to each other so that we know this is 2 times the square root of 5. Okay, so let's look at 48. So we're going to take the number 48. We're going to look for factors of 48. 1 and 48, 2 and 24, 3 and 16, let's see, 4 and 12, 5, 6, 6 and 8. All right, so now, again, this is where the perfect squares need to be memorized. You need to be able to rattle off to me 1, 4, 9. So you're looking at these numbers for perfect squares, and you want to find the largest perfect square. So right away you see a 4, but the other perfect square is the 16. So you always want to choose the largest perfect square to break down your square root. So we're going to break down the square root of 48 into, and I'm going to do it a little lower down here. So the square root of 48 is going to be the square root of 3 times the square root of 16. You're going to take the square root of the one that's perfect. So the square root of 16 is perfect, so it comes out in front as the square root of 16 is 4. The square root of 3 is a decimal, so we just leave it as that. So that's 4 times the square root of 3. All right, 5 times the square root of 72. So we're looking for factors of 72. 1 and 72, 2 and 36, 3 and 24, 4 and 18. All right, so right away you've got to be able to say, all right, look at this list. The perfect square has got to be jumping out at you. So 2 and 36. 36 is the largest perfect square. So you're going to break down this square root. So that's going to be 5 times, you got to keep the number still on the outside, the square root of 2 times the square root of 36. So if it's perfect, you're going to go ahead and take the square root. So this is going to be 5 times this cancels because we take the square root of it, and we still have times the square root of 2. So this is what was meant, is when you take the square root of a number and there's a number on the outside, you go ahead and multiply those. So the final answer, 5 times 6 is 30, square roots of 2. Okay, next, 3 times the square root of 125. So we're going to take the number underneath the radical and we're going to factor it. So look for factors of 125, 1 and 125. Again, you can put this in your calculator. You go to y equals and you would put in 125 and you would divide that by x and go to the table. And that's going to pull all of them up for you, 5 and 25. And I think that's going to be about it for 125. Because luckily, what I see right here is we have a perfect square. Because if you take the square root of 25, it's going to come out to 5, which is perfect, and that's what we would like. So we're going to use these two numbers, and we're going to break down that radical. So this becomes 3 times the square root of 5 times the square root of 25. If you have a perfect square, you go ahead and take that square root. So the square root of 25 is 5. So that goes away, and we still have times the square root of 5. Anything out in front, any whole numbers that come out in front get multiplied together. So 3 times 5 is 15. Square root of 5 is not perfect, so it does not come out of the radical, stays in. All right, one more, 33. If we look for the factors of 33, it's going to be 1 and 33, 3 and 11, and there's nothing else there. So if you look at the list, 1 is not a perfect square, 33, 3, 11. So none of these are perfect squares. So since none of them are perfect squares, this is the most simplified form of the square root of 33. So not all radicals can be simplified. So this would be a case where not all of them can be simplified. All right, this is how to simplify them.